Hi guys, in this video I will cover the template method design pattern. The purpose of this design pattern is to define the skeleton of an algorithm in a method and allow subclasses to define detailed instructions for individual steps of that algorithm without changing its structure. Let's take a look at the UML diagram. I have an abstract class named abstract algorithm. This has a public method named algorithm and a few protected methods that I named step 1, step 2, and step 3. Let's take a closer look at the public method algorithm, which I have shown over here on the right. This method would implement an algorithm. You can use conditions, you can use loops, you can use whatever you need to implement that algorithm. But for those steps that may change, you would create methods and delegate that implementation to those methods. So I may do something in the beginning, I call a method, then I have something hard-coded here with conditions, loops, or any other instructions. And then again, I have another step where I call the method and leave that implementation to that method. And then maybe I have another step where I call another method. You could have one method call in the algorithm. You can have as many method calls as you want. So there doesn't necessarily have to be 3 method calls like it is shown in this example. It really depends on the implementation of that algorithm. Now these protected methods could be abstract or they could be implemented. If you do provide an implementation, it could serve as a default implementation of that algorithm. Now, the full algorithm is defined by inheriting from this abstract class and overriding any of these methods. For abstract methods, the subclass is forced to provide an implementation. And in this implementation, it would provide the detailed instructions how this step of the algorithm is performed. If there is already an implementation in the abstract class, the subclass may choose to change that implementation of the algorithm. But the important thing is that the subclass only provides an implementation for individual steps. It does not have to rewrite the entire algorithm. The template of that algorithm is defined in this public method of the superclass, and then the subclass only changes small steps of that algorithm by overriding or implementing one of these methods that are called in that algorithm. Now this is still very abstract. So let's take a look at a close example. Let's say I want to have a pizza maker that makes pizzas. Now making a pizza is a standard way. I make the dough, I create the pizza, I add some ingredients, and then I bake the pizza, and the pizza is done. But that algorithm slightly changes depending on what kind of pizza I make. So I could make a cheese pizza where I add tomato sauce, I add a bunch of cheese, I bake it, and then I return it. Or I could make a pepperoni pizza where I add tomato sauce, cheese, and pepperoni. I might bake it a little bit higher to make it more crunchy. So the algorithm always is the same. I make the dough, I make the pizza, I add ingredients, and then I bake the pizza. But depending on what type of pizza I make, certain steps of that algorithm slightly change. So how would this apply to this diagram here? The abstract class I could name pizza maker. The algorithm method I could name make pizza. And then in this make pizza method here, I would first maybe make the dough, create the pizza. Then in another step, I would have a method that I call add ingredients, and I pass the pizza to that method. And then I have another method called where I bake the pizza. Now let's see how this diagram changes for this specific use case. Here I have again the abstract class. In this case, instead of calling it abstract algorithm, I call it pizza maker. The public method I name make pizza, and it returns a pizza. And then I have two protected methods, add ingredients, that is passed a pizza, and bake, which is also passed a pizza's argument. The make pizza defines and implements the template of that algorithm. Then I have two concrete subclasses. One class is named cheese pizza maker and one is called pepperoni pizza maker. These override or implement these protected methods. Now in the example that I will use, I will leave add ingredients as abstract method, and the bake method I provide a default implementation that always bakes the pizza at a certain degree. So these two subclasses will be forced to override the add ingredients method and provide an implementation. Besides these classes, I use some more classes. In this example, I have an ingredient interface and a few classes that implement this ingredient interface. These classes are named tomato sauce, cheese, and pepperoni. So these will be the ingredients that I add to the pizza inside the add ingredients method. Now let's take a look at the source code. So here I have the abstract class pizza maker. There's the make pizza method. This method first creates a new pizza, then it calls the add ingredients method and passes the pizza object to it. Then it calls the bake pizza method, passes the pizza to it, and finally it returns the pizza. Now the add ingredients method is left as abstract. There's no implementation for it. So I force subclasses to implement this method. The bake method, however, is implemented here, but subclasses may still choose to change that implementation. In this default implementation, it bakes the pizza at 400 degrees for 15 minutes. Now let's take a look at the concrete subclasses of this class. The first subclass is named cheese pizza maker, which extends pizza maker. This is now forced to provide an implementation for the abstract method. So I use the add override annotation and I implement add ingredients. And what this does is it adds tomato sauce to the pizza, it adds cheese to the pizza, and because it's a very cheesy pizza, it adds another layer of cheese. And that's all there's to it. The cheese pizza maker does not have to rewrite the entire algorithm. The algorithm still stays the same, as you can see. The only thing I did here is I changed one small step of that algorithm that is specific to a cheese pizza maker. Let's take a look at another example. Here I have pepperoni pizza maker, which also extends from pizza maker. And again, it implements the add ingredients methods. In this case, it is slightly different. I add tomato sauce, I add cheese, and I add pepperoni. So again, you can see the algorithm stayed exactly the same. The only thing that I had to change in the subclass is to define detailed instructions for one specific step. Now what I could do optionally here is I provide a different implementation for one of the methods that are already implemented in the superclass. So in this case, it's the bake method, and let's say I want to bake it a little bit different, the pizza. So I do system out println baking at 425 for, let's say, 17 minutes. And now you can see the only thing that I implemented here is another step of the algorithm. I changed it a little bit because I didn't want to leave it as the default implementation. But again, I just changed one step of the algorithm. I don't change the structure of it at all. Now let's take a look at a main method. So here's the main method. I create an object of type pepperoni pizza maker. I call make pizza, which is the template method algorithm. It returns a pizza, and finally I output it to the console. Now when I run this, You can see it outputs, it's baking the pizza at 425 degrees for 70 minutes. And the pizza that I get is a pizza with tomato sauce, cheese, and pepperoni. Now, if I change pizza maker to cheese pizza maker, and I run this again, I'm baking the pizza at 400 degrees for 15 minutes, and I get a pizza with tomato sauce, cheese, and cheese. So the algorithm in both cases was the same, but the detailed instructions of some of the steps change slightly in those subclasses. I hope this gives you a good idea how the template method design pattern works. Thank you for watching.